Okay, and now we are going to continue our process of talking about IP networking by talking about converting binary numbers. Now, you are probably familiar with the fact that we as humans use what's called base 10 or decimal for our counting because, well, we have 10 fingers, and therefore it's easiest for us to understand. Computers, on the other hand, use binary or base 2, simple on and off configuration to count their numbers. And so we as engineers and as programmers and as computer people need to know how to convert what we see as decimal into binary and vice versa. So to get started on this, a little bit of terminology. First one is a single binary digit. So if we have, for instance, a 0 or a 1, this is referred to as a bit. A single digit is referred to as a bit. If we have 4 of these bits together, it is referred to as a nibble. So if you're not just going to have a bit of something, you're going to have a nibble of something. And then if we have 8 of all of these digits or bits, then we then have a byte. I always think about it of how much am I going to eat? Am I going to have just a little bit? Am I going to nibble on something, or am I going to bite right into it? Hooray for the people who came up with these terms. So now that we have our terminology, a bit, a nibble, and a byte, these are helpful because we normally, in computer world, work with what's called a byte, or 8 binary digits, specifically when we're talking about IP networking. Our IP addresses, for instance, 192.168.42.17, is in fact composed of 8 bytes. So there's one byte with a dot, another byte with a dot, another with a dot, and the fourth one right there. So we have 4 bytes that we are working with. So we need to know how to convert this, for instance, this 192 into binary so the computer can understand it, and then back into decimal so that we can understand it. Well, if you remember your math classes, for the most part, if you remember the process to do a math problem, the work itself was fairly simple. If you didn't remember the process, the work wasn't simple. But if you did remember the process, it was fairly easy to walk through the process. And that's kind of how it is with converting binary numbers. And there's 2 different processes to worry about. First one is converting binary to decimal. And for that, what we do is we mostly add. So a little bit of background first. Here I have a spreadsheet open. And I have my decimal numbers here, which you may recall are in fact referring to binary. So we have the number 1. 1 times 2 is 2, times 2 is 4, 8, 16, 32, 64, and 128. These are essentially base 2, or multiples of 2s as we move along. Times 2, times 2, times 2. Great. Now the column above that talks about an exponent. Now this is where, if you get lost here, don't worry about it. It's not super important at this point. However, the exponent, for instance, 2 to the 1. Actually, let's go start with 2 to the 2. 2 exponent 2, sometimes also written 2 little 2 up above it, refers to the number 2 being multiplied twice. So this is 2 times 2, which equals 4, which is that right there. If we look at the next one over, 2 to the 3rd, or 2 caret 3, is 2 times 2 times 2, which is equal to 8. And 2 to the 4th, 2 times 2 times 2 times 2, 2 to the 5th, and so on and so forth. And so these are how the exponents start working into our decimal numbers so that we can start understanding exactly what's happening. After a while, this exponent information will start to make more and more sense. If it's confusing to you right now, don't worry about it. It's a concept that I always had a hard time with when they tried to explain it in high school. And even when I taught high school, I had a hard time explaining it. So don't worry about it. It may make sense eventually. Just figure out the way that works best for you. So now that we have our exponents and our decimal references, what we do now is we think about a binary number. Now, like I said, we normally deal with 8-digit binary numbers, so I'm just going to randomly create or randomly write in here an 8-digit binary number. So 11001001. I put a space right there simply for my own reference, because I know that's half on one side, half on the other. It's a little bit easier to read. The computers don't actually see that space, so it's just for our own purposes. So what I do with this number is I essentially start filling in these different columns here with the ones and zeros. So for instance, I have here a 1, so I'll put a 1 there. Right next to that I have another 1, so I'll put a 1 there. And then next to that I have a 0 and a 0, a 1, 0, 0, 1. And I'll actually do that in Excel. Oops. And there we go. So now what I do is essentially is I look at all of these decimal numbers right here, 128, 64, and so on, everywhere that I have a 1. So here I have a 1, here I have a 1, here I have a 1, and here I have a 1. And what I do is I essentially add all of those together. So 128 plus 64 plus 8 plus 1. Let's pull up the calculator and find out what that actually is. 128 plus 64 plus 8 plus 1 is 201. So therefore, this decimal number 11001001 is 204. And it's just that simple. It's just that simple to be able to convert a binary number into a decimal number. Just simply break it out according to these columns here, write out the ones, and then add them up. So let's try that again. Get rid of these bolds here and this line right here. So let's try that again. Let's try 0, 1. Excel's going to freak out on me there. 0, 1, 0, 0, space 0, 1, 1, 1. There we go. And so I break it out into the process, break it out into the individual columns, 0, 1, 0, 0, 0, 1, 1, 1. I now look at the columns up above. I have right here 64 plus 4, that's 68, plus 2, that's 70, plus 1 is 71. So my number is 71. Let's try that one more time. 1, 0, 0, 0, 0, 1, 1, 0. These are essentially random numbers. They don't actually mean anything. Don't worry about them just yet. So 1, 0, 0, 0, 0, 1, 1, 0. And again, everywhere that there's a 1, I start adding up the numbers. So 128 plus 4, that's going to be 132. Right. Plus 2, that's 134. And there we go. My number is 134. And it's that simple of a process. Again, all I have to do to start this out is I start drawing out my digits up here. So if I was to do this on a whiteboard or on a piece of paper, 1, 2, 4, 8, 16, 32, 64, and 128. That's a 2 there. If you get confused, remember, it's just 1 times 2 times 2 times 2 times 2, and so on. I draw a line. I then find my binary number. Let's try 000101111. That's a horrible writing of that. Let's try it again up here. 00010111. There we go. And so now I take that binary number and I simply fill in these columns. My first 3 are zeros, 1, and then 0, 1, 1, 1. And now everywhere that there's a 1, I start adding in. 16 plus 4 is 20, plus 2 is 22, plus 1 is 23. And there you go. That's the process of converting a binary number into a decimal number. Write out the multiples of 2, all the way up to 128, and then fill in all the digits, and then add up everywhere that there's a 1. Piece of cake, if you remember the process. Well, hey, that's a great process. We were able to easily convert. Once we had the process, we were easily able to convert from binary to decimal by simply adding together everywhere that there was a 1. Awesome. Well, then, now that we can convert from binary to decimal, the question is, how do we convert from decimal back to binary? Well, it pretty much happens the exact opposite, except this time we're subtracting. So if I come back here to my Excel spreadsheet, what I'm going to do is I'm going to copy these top 2 lines here, create a new spreadsheet, and let's go ahead and start off with a number, let's say 137. So what I do here is, instead of adding all of those decimal numbers or all those binary numbers together to create a decimal number, what I do now is I take my decimal number and I subtract binary wise from it. What that means, I have right here 137. My very first binary digit is 128. Can I subtract 128 from 137? And the answer is yes. Yes, I can subtract 128 from 137. And because I can, right here for my binary, I write the number 1. Okay, so what is 137 minus 128? 137 minus 128 is 9. Got to confirm my math there. I'm not super fast sometimes. So 137 minus 128 is 9. So now that I have this one digit here, 9 is my new number. So now I start looking at 9 and the next column. Can I subtract 64 from 9? No, I cannot. Not in stay positive numbers anyways. I cannot subtract 64 from 9. Therefore, the column right here for 64 is a 0. All right, continue on. Can I subtract 32 from 9? No. Therefore, my answer is 0. Can I subtract 16 from 9? No. Can I subtract 8 from 9? Yes. I can subtract the number 8 from the number 9. Therefore, I write a 1 here. And then my number 9, I subtract 8 from. 9 minus 8 is 1. And now at this point it's really, really simple. Can I subtract 4 from 1? No. Can I subtract 2 from 1? No. Can I subtract 1 from 1? Yes. And then lastly, 1 minus 1 is 0. And therefore my decimal number 137 now has the binary number 10001001. All right. Well, hey, that's not actually that hard of a process again. Again, if you know the process, it's just following it through. So let's try another number. Let's try 213. So can I subtract 128 from 213? Yes, I can. Let's see. 213 minus 128 is 595. If you're watching this video, feel free to correct my math, but it looks like 95 to me, so I'm starting with 95, or continuing with 95. So that means my number now is 95. Can I subtract 64 from 95? Yes, I can. So I put a 1 in there. 95 minus 64, that's 31. So my number is now 31. Can I subtract 32 from 31? No, I cannot. Can I subtract 16 from 31? Yes. 31 minus 16 is 15. Right. So that means my now working with 15. Can I subtract 8 from 15? Yes. 8 from 15 is 7. I know that one off the top of my head. Can I subtract 4 from 7? Yes. 4 from 7 is 3. Can I subtract 2 from 3? Yes. That's 2 from 3 is 1. Can I subtract 1 from 1? Yes. And now that I've gone all the way through, my number is now 1101 1111. And that's how we convert decimal into binary. So let's try a different number. Let's try a small one. Let's try 49. All right. So again, starting from scratch, can I subtract 128 from 49? No. Can I subtract 64 from 49? No. Can I subtract 32 from 49? Yes. 49 minus 32 is 17. So I'm now tentatively working with the number 17. Can I subtract 16 from 17? Yes, I can. 17 minus 16 is in fact 1. Now, if you're thinking ahead, you know exactly what the answer is at this point, but we'll follow the process anyway. Can I subtract 8 from 1? No. Can I subtract 4 from 1? No. Can I subtract 2 from 1? No. Can I subtract 1 from 1? Yes. Therefore, my binary number is 0011 0001. Great. Piece of cake. Right? Maybe? Let's try a hard one. Let's try something really big here. Can I subtract 128 from 255? Yes, I can. Let's see. 255 minus 128 is 7 to 127. That number looks oddly suspicious. Well, let's keep going. So if my number is now 127, can I subtract 64 from 127? Yes, I can. 127 minus 64, 63. Oddly suspicious. I have 64. I now have 63. Well, let's keep going. Keep working the process. Can I subtract 32 from 63? Yes, I can. 63 minus 32, 1, 3. 32, 31. Sensing a pattern here. This will start making a lot more sense as we get in closer. 16 from 31. Yes. 31 minus 16. It's 5, 1. 15. Can I subtract 8 from 15? Yes. 8 from 15, I know off the top of my head, is now 7. Can I subtract 4 from 7? Yes, I can. 4 from 7 is 3. Can I subtract 2 from 3? Yes. 2 from 3 is 1. Can I subtract 1 from 1? Yes. And that ends up with the binary number 11111111. All ones in our binary digits, which means, in fact, for an 8-bit number, 255 is the largest 8-bit number we can have. Largest 8-bit number of 255. In fact, as you look around and you see IP addresses on the internet, the number 255 is the largest IP address you will see, or IPv4 address that you will see out there. Now, for those of you who aren't necessarily concerned about IP addressing and are more concerned about how binary works with the rest of the world, and how you might be able to use it, say, for programming. Well, let's say you're creating a program. Let's say you're creating a software program for a game. And you start coming up with a whole bunch of different things you want to track with some person or some actor in your game. So let's say you have like Save the Princess and Find Treasure. Found Map. Missed the Trap, and so on. So there's a couple of different ways I can do this if I'm writing a software program. First thing I can do is I can create a variable in my program called Saved Princess. Did I save the princess? True or false? Did I find the treasure? True or false? Did I find the map? True or false? Did I miss the trap that I was supposed to go into? True or false? And so I can create all these different variables, and then when I save the game, I have to save, in this case, 4 different variables. Or, since all of these are true and false questions, what I can do is I can start putting these into a binary configuration. So, for instance, did they save the princess? No. Did they find the treasure? No, not yet. Have they found the map? Yes. Did they miss the trap? No. And now we can start putting the binary additions into this, or convert this binary number into a decimal number. So, for instance, if we put our binary numbers or binary digits up here, binary placements, there we go. Well, now suddenly we have there's no ones, there is a 2, no 4s, and no 8s. Therefore, my ultimate number here is 2. So now, instead of saving 4 different variables, one for did they save the princess, did they find the treasure, and so on, now I can only have to store one number, which is the number 2. And then conversely, I could do the same thing the other way around. I can then convert the number 2 back into, did you miss the trap? Did you find the map? Did you find the treasure? And did you save the princess? So I can now use binary to convert all of these different settings into a single number, and then back the other way. So then I can use it not just for IP addressing, which is what we'll be talking about a lot of times, but I can also use binary for more interesting things in programming languages, which is actually used quite a bit. All right, so there we go. We have our bits, we have our nibbles, we have our bytes, We normally use bytes for most everything out there in the world. Occasionally we will use a nibble or a bit. In order to convert from binary to decimal, we add these numbers out. We break them out according to our powers of 2. So 1, 2, 4, 8, 16, and so on. And then we simply add up those placements. And then in order to convert from decimal to binary, we subtract. We create our list of all of our powers of 2, 1, 2, 4, 8, 16, and so on. And then we subtract from our decimal number in order to get the placements for the binary.